Good morning, Vincent. Oh, I put my camera on the other side yesterday. Let me put it back here so I can look you in the eye. There. Good morning. Yeah, we have a first viewer, which means that we can get started. Today looks like a lot of fun. Really looking forward to doing this one. Don't think it will be too hard. But first, I want to talk about something someone posted on Clojurian's Slack, an issue they had. And we're also going to go over the comments, and there'll be a couple more things to talk about there. Let me switch. That means that post-it can go until tomorrow. Yeah, so someone, I think it was user Ken J. Oh, a couple more viewers. Hey, everyone. So I think it was user Ken J who posted on in the Advent of Code channel on Clojurians. So they had a solution for yesterday's problem with loop recur. And inside that loop recur, they were building up a long sequence by basically, continuously concating stuff onto an existing sequence. So it became sort of a concat of a concat of a concat. And it resulted in a stack overflow. And they said, well, that was really surprising because I thought concat was lazy. Well, concat is lazy, and that is why you're getting the stack overflow error. And I'm going to demonstrate that, and then I'm going to explain what's happening, because this is a classic Clojure gotcha. I still remember the first time that I lost, way too much time trying to figure out what on earth was happening. So okay, consider this. Let's take a range of 100,000 numbers. That should be plenty to overflow our stack, and then I'm just gonna turn those into just single element sequences, right? So now we have a sequence of mini sequences. And then I'm gonna say reduce concat and stick that into a var. So this is fine, right? Runs instantly, doesn't do anything, no problemo. Except that as soon as you try to get even just one element out of this thing, boom, stack overflow error. And you see when you look at the stack that it's inside concat, seek gets called. The seek implementation in this case is part of the lazy seek. The lazy seek calls concat again, which calls seek again, which calls lazy seek again, which calls concat again. So, okay, first of all, what does concat actually do? If you look at the implementation of concat, I'm simplifying it a little bit here, but basically, concat, say you have x, y, two sequences. It basically says if let x seek or s, I guess they call it s seek x. So you may remember seek is coerces something to a seek, but also the contract of the seek function is that anything that's empty returns nil, and so it's a common idiom to also use this as an empty check. So the else branch in this case is just y, right? Like if I'm concating an empty sequence onto some other sequence, then that's just the second sequence. Now the first case, this bottoms out by calling cons. So it conses the first element of this sequence onto, and I guess I'll call my concat on the rest of s plus y. Right, so it kind of recursively takes the first element of whichever of the two sequences that still has elements, uses cons as kind of the lowest level primitive to gradually build up that seek. but at each step of the way, this gets wrapped into a lazy seek. And so lazy seek is a macro, which wraps some form which needs to be seekable, or seekable, I guess, seek or seekable, and it'll call the code inside the block as soon as you try to access that seek. Which REPL is it? Can I do this? Then it goes there. Great. Cider REPL. Here we are. Okay. So when I now it realizes it because Cider prints it, so it needs to realize it. But if I stick a nil here, so it doesn't need to realize the sequence, right? That doesn't print anything. But if I say first, then it prints the realizing because the lazy seek gets realized. So how does that work? How is it able to do that? Well, if we look at lazy seek, so class lazy seek, sorry, should have put maybe a trigger warning on that. Gonna see some Java code here. So lazy seek is a class which implements iSeek. So this is the seek interface. iSeek just has a couple methods: first, next, more, which in Clojure core is actually rest, and then const to add something back onto the seek. So this is kind of the lowest level seek interface. And lazy seek is just a wrapper around an IFN, around a function. And then here it actually starts implementing the seek interface, and that calls seek, and that calls sval. And here we see, okay, so this is the point where it says, like, okay, if we have a function, then invoke it and assign it to an instance variable, so that now we have the realized seek and we can, do seek stuff on it. So yeah, long story short, a lazy seek is really just a function in disguise. It's really just a Lambda in disguise, which gets called as soon as you access the sequence. So what happens here, by doing this reduce concat, we're building up this huge nesting of lazy seeks. And as soon as it tries to get the first element, it needs to realize the outer one, but then that will realize the next one, and that will realize the next one. And so, that's what's happening. That's why you get a Stack Overflow. The funny thing is that now, so that when I called this the first time, it overflowed. But the second time I can get the first element fine, because it did manage to realize that outer lazy seek. At least, that const worked. I don't know. I don't have the, not sure exactly the perfect details of what's going on, but like, if we would realize this whole thing, I don't know how many we would be able to take. It actually even only just shows it as a one element sequence. So that's kind of funny, right? So like it blew up the first time, but then somehow it kind of realized it and left it in an inconsistent state, which is kind of bonkers. Maybe that should actually be reported as a Clojure issue, because that does not seem quite right. But yeah, that's how it is. So rule of thumb, be wary if you ever see reduce concat, change it to apply concat. That's really all you need to do. And now this works fine. And I can traverse this thing all the way to the end. So yeah, if I don't know if CLJ Conto already has a rule for reduce concat, but like reduce concat is an anti-pattern. Change it to apply concat, does the same thing, but you don't have the same issue. I'm gonna leave this here for reference. quickly go over yesterday's comments. Yeah, so Bob sent in his solution. Got this one here. One thing I noticed here, I guess, I'm not sure if this is intended as a docstring, but watch out, docstrings go before the argument vector. The rest seems pretty reasonable. So this is, you know, to parse a single line, just does some reject stuff and returns a vector with a map. So that's what you get here. And then it defines a couple things in a let here, and then, you know, returns a map with the results. To have a better look at this, I'm gonna change these into defs. So we can more easily check what these are actually doing. So this is parsed. Parsed is a map apparently. Yeah, so this is kind of similar to what I had, except he's using maps instead of vectors. I really, somehow, the place where Emacs is opening that, why can't I, is there Control X, Control minus? C, Control minus? I'm pretty sure if I change this to a smaller font, no, now it, wait, did it change the font? Yeah, now it shows it on the right, which is what I want. I don't know why it does that, but now it's there, except it's not. Sorry folks, I know this is not super compelling. And I actually wanted to have my result buffer there. Yeah. Okay, so that's parsed contain tree. Let's look at the contain tree for dotted teal. What does this look like? Not evaluated yet. Okay, so here it recursively just sort of get nested sequences. Yeah, fair enough. And then can hold bags bag name. So here it then, how does it call this? Oh, this is, yeah, this is already the implementation for the second part. This is the implementation for the first part. And yeah, it's, I mean, my general impression also from looking at some other solutions is that I made it a little bit too complicated yesterday. One thing that's interesting here is that some solutions did this where they kind of account for the bags themselves as they go a level down. Whereas what I did and what I saw Vincent also did was sort of have this one level higher, which meant that we had to decrement the final number because we were also counting the outer bag, which here Bob doesn't need to do. Yeah, this all seems like a fairly straightforward and reasonable solution. Not too much to remark here. I don't think there's anything too special to point out. Saw some cool solutions. Saw someone do it with Loom in a quite concise way. Thought that was nice. And also some folks that used treeseek, which is one of those functions that it's easy to forget that it exists. Oh, how do I not have Clojure string here? Yeah, so treeseek returns a lazy sequence of the nodes in the tree. So you give it a branching predicate, basically checking if a node is able to have children. Then you have a function which returns the children for a node, and then you give it a root, and so this is the root of your tree. And so this way you can turn any arbitrary nested sequence, nested structure into a sequence. And then you can count that, which is what we needed yesterday. So I saw some solutions with treeseek as well. Good to know that exists. Might come in handy later on in the advent of code. So would treeseek be a good solution to this? Absolutely, definitely seen some of those. Hello from Washington, D.C. area. Thanks much for doing these videos. It's fun to watch and compare your solutions to mine. Hi, Dave. Really cool that we got viewers from all over the world. Please do keep leaving your comments. Really appreciate it. Any info or resources how the whole binary bit shifting works conceptually? This is still from day 5. Puzzle 05. Where is my 05? Yeah, where I first did the bit shift and then later on realized that I could actually just multiply by 2. I don't know at what level I need to explain this. I mean, the basically what, you know, we had a binary number like this expressed as bits. And if we go back to my original solution, where I said bit shift left and then bit or, and in that case D1, yes. Yeah, so how does this work? Basically, we start from 0. If I bit shift that to the left, that's still 0. And then I say or 1, so that turns in 1. Now when the next iteration for the next bit, basically I shift that to the left so that becomes 1, 0. And so by bit shifting 1 to the left, I know that the last one is always 0, and then I can OR that with either a 0 or 1. And so, yeah, basically I'm just sort of from right to left rebuilding that binary number. And how does that relate to the puzzle? Well, that's the way that they're splitting these rows, right? In like, okay, 61st front or 64 back. Positionally, this is 1, right? This is 4, 2, this is 4, this is 8, and then here it becomes 16, 32, and then 64. So if this bit is 1, that adds 64 to the number, which means that we're now in the second half of the plane where the numbers are higher than 64. And then if we need to split that in, like decide between the front or the back half of that, it's like, well, you know, if you add 32, which is, you know, which means that there's a 1 here, then you're in that half. So I don't know, there's probably better resources that explain this better, but I hope that kind of makes sense. EOSFK, great font. And then, yeah, one more question, it's kind of a big question. Do you have plans for a new Lambda Island videos? I could talk for an hour about this. Short answer, yes. Long answer, it's complicated. So, but let me give you a small status update of what's happening with you know, lambdaisland.com. So I started Lambda Island almost 5 years ago. Mostly did it by myself for the first 3 years. Took a lot of work and a lot of stress, and it never made much money. Not only that, it never made much money, it also just, it doesn't have a lot of reach, right? Like, and so when I put like the videos I have on lambdaisland.com, they take about a week of full-time work to make like one 10 to 15 minute video. And it's a lot of work, it's a lot of stress, and it's extremely anticlimactic to then like put that online and basically nothing happens. Like 50 people watch it. There's no new signups, there's no comments. It just did not seem like a good use of my time. And like I said, it wasn't making significant money. So I've been focusing more on client work. Now, in the meanwhile, some stuff has been happening. So 2 years ago, I started Guy1, which is now my company, which runs Lambda Island. We also did the Heart of Clojure conference last year as Guy1. And it's what I do, or the company that does a bunch of client work. We work with Next Journal, with Pitch, with 11. And so Guy1 is 5 people now. So that's quite amazing. Several people joined only quite recently. We were like 2 to 3 people for the first year or two. But we're 5 people now, and we're working on a bunch of different things. And everybody's actually quite excited to put some more work and some more love into Lambda Island itself. I mean, we got the new branding now, which is super nice. Lubov did a really great job on that. Someone's been working hard on a redesign of the site, which we hope to launch early 2021. Meanwhile, of course, we have other stuff, like we have Clojurian's log, which is also a community thing we do. So people have been working on that. And we've been talking about what we want to do in terms of content. Now, it's still a bit of an open question. The main thing that we know is that we want to have some more beginner content. And so that mostly is going to look like a beginner guide, which really takes people from installing Java and Clojure. Hey, Mitesh is on the stream, so he's one of the people that joined Oxalorg in most places as a handle. So yeah, we are definitely gonna come back with Lambda Island in 2021. We hope to launch the new site early 2021. We have some content work that's in the pipeline and some more content work that we're talking about. Will there be more videos? I mean, so one of the reasons I'm doing this streaming now for Advent of Code is to sort of get more comfortable and figure out my streaming setup and figure out what I can do this way. Because like all the time that I'm gonna spend, on like 24 days of Advent of Code is probably less time and work than a single 15-minute Lambda Island video. And so, we want to experiment a little bit with different formats like that. We'll see if maybe other people can work on videos or if we can collaborate with videos. But we're also going to experiment with non-video content. So it's still too soon to say exactly what all of that's going to look like. But we're definitely going to come back with new stuff in 2021. That's I can't say that much. I hope that answers your question. Couple people have asked me about this, and I'm not, it's not a secret how things stand. I've been prioritizing other things. But yeah, we are coming back. All of that out of the way, high time we jump into today's exercise. And like I said, I think this one is going to be a lot of fun. Just a sip of tea. Still converting tea into code. Okay, so the story goes, we're finally on the plane, but the kid sitting next to us has, a little handheld gaming device, and the code that's running it has an infinite loop, and so kid is unhappy. We need to fix it. So we're going to implement a tiny virtual machine which just has a single register which we can add to with the accumulate instruction. Then we have a jump instruction which changes the program counter, so it jumps ahead to a certain amount of positions. And then we have a no op instruction which just does nothing. And so the second argument is a positive or a negative number. In the case of nop, we just ignore it. In the case of ec, we add it to the register. And in the case of jump, we jump. And the first question is, just before we get to the infinite loop, so just before visiting an instruction which we already visited before, what is the value in the accumulator? And yeah, let's call it test input. String split lines is a good candidate for this now. So if we split that, actually I don't even need split lines. I was thinking, like, because I saw some other folks just doing, you know, like an RE seek on the whole input, and why not? You know, like regular expressions are fine for this, and unlike some other languages, you know, it's happy to scan across new lines. It doesn't really treat those special. So we have word plus or word 3 space and then plus or minus, plus minus, and then one or more digits. What does that look like? Perfect. Yeah, and let's coerce that a little bit more. Let's say we no, let's do a for. For loops are always nice. Or I should say list comprehensions, because I feel like there's sometimes a little bit of confusion with people coming from other languages when we say for loop. I mean, these are not like for loops in most languages. They're really more like list comprehensions. Gonna call this operator an argument, and I'm gonna use Vincent's read string trick. I think I'm only curious if this, yeah, this reads fine. So that means that I can turn this, and I'm gonna use keywords for this just because we can, because it's Clojure and read string of the argument. Yeah, that looks awesome. And I'm gonna turn this into a vector because we wanna be able to, you know, get indexed entries, because we're gonna have those jumps where we need to jump to different positions. Yeah, defn parse input, test input. Oh yeah, I remember now there was one more comment on day 5, I think. No, was it on day 5 or on day 6 where they asked, like, where's input to map? Input to map's right here. So it was getting not defined on input to map. I mean, check the code on GitHub. It's right there. Okay, so today's puzzle. This is our input, and then just gonna do a loop recur, and I like to call this kind of thing context. Yeah, so let's say PC. PC stands for program counter. This is what on computers, you know, CPU architectures, you call the register which contains the address of the current instruction. So we're just gonna use that, classic. And then our accumulator starts at 0. And then yeah, let's say, so we have open arg by doing a get. So we can do a get on a vector with a numeric argument. Let's also destructure this. How about that? PCAC as context. Get what do we call this? So let's say let program parse input test input. Test input. Here it's just input. Defn. I wonder if this is still, I mix this up regularly, and I wonder if it's still a leftover from my Ruby days where, you know, def creates a function. Okay, so we have our program. We're just going to loop get the current instruction. You're right, it is unlisted. I can change that. I mean, the thing is, I'm deleting these live streams afterwards and uploading the video afterwards for two reasons. Creates higher quality video, and yeah, the live streams show up separately from the regular videos, which I find super annoying. So that's kind of why I had it unlisted. But yes, while the stream is on, I guess people should be able to find it. I always share the link on Twitter and on Clojure and Slack, so you can keep an eye there. But yeah, it should be public now. So let's get the current instruction with the program counter. I'm also in this context here. Let's pull this out, say initial context. So we have our two registers, and then we need to keep track of which instructions we've already seen. So I'm just going to do that with a map. And then maybe first check here for a terminal condition. If seen program counter, then return accumulator. Else process the instruction, which means we get the current instruction from the program with the program counter, split it up into operator and argument, and then just a simple case. So we have nop, jump, and ack, or ack and jump. Nop just means that we recur, but we update the context by incrementing the PC counter and adding the current PC counter to the instructions that we've seen. If it's an accumulate, then we need to update the accumulator register by adding the current argument to it. We still update the program counter because we need to go to the next instructions. And again, we add the current instructions to the instructions we've already seen. And then jump. What does it mean to jump? We don't touch the accumulator. We add the argument to the program counter. So now we, instead of just going to the next instructions, we jump to an offset. And again, you know, we make sure that we mark the current instruction as seen. Seen is not yet defined because I need to destructure it. Long cannot be cast to IFN on line 38. Why is that? Oh, because I need to add it, not just call it. Okay, so PC6 accumulator is 1, but we're supposed to get 5. So PC6 1 2 0 1 2 3 4 5 6. Okay, let's debug this a little bit. Let me know if you already see what I'm doing wrong. I think it might be if we need to like do it before or after. I'm not sure. Oh, that terminates faster than I expected. So PC 0. I'm gonna quickly put this description on my other monitor so I can compare the two with what's happening here. First, the knob 0 does nothing. Yes. Actually, let's print. Let's do this. Yeah, so first the knob 0 does nothing. Then the accumulator is increased from 0 to 1 by the ACK plus 1. So we see that happening, yeah. Then jump 4 sets the next instruction to the other wait, what's happening here? So PC 2, okay, it does jump. I'll do pure and done context. Oh, am I missing a case somewhere? Because it doesn't get here. But if there's no matching case, it would. Oh, I'm not recurring. Oh my gosh. Okay, now we get 5, which is the result we want. Good morning, Dustbowl. Yeah, let's take those print lines out again. I think our little virtual machine is doing its job. Let's go fetch the input for day 8. Yeah, someone also pointed out, so I've been using this IO reader a lot, right? Especially when I want to use line seek. And yes, actually, this is not a good practice. So IO reader opens a buffered reader, which means that yeah, we're holding a resource on that file. We're holding an open file handle, and so when you're done with this, you're supposed to close it, calling the close bang. What does with open call? Come on. Yeah, finally dot close. But isn't there also just a close in Clojure core? Oh no, maybe it's in IO close. Yeah, anyway, so yeah, what if you're gonna use IO reader, what you're supposed to do is something like this, you know, get that reader and then do whatever you need to do with it, and then close it, right? To make sure that properly cleans up, and yeah, so it's just I thought there was a wrapper for the dot close, but no. Okay, you know, you just, it's a closable interface. A lot of Java stuff. Hey Alexander, a lot of Java stuff implements this closable interface where you can call dot close on something, and so there's basically to do this pattern, but then also to do it in a try finally to make sure the close really happens. You can use with open. Always thought with open was a bit of a funny name because it's really with close. So yeah, you do with open, you do whatever you need to do with your reader. The result of with open is just the last value in this block, but then when you exit that scope, it automatically closes. Now be careful. I'm pretty sure if you do this, and then you're going to process that seek outside of this with open, that's going to not work because this is a lazy seek. So by the time it tries to realize it, you're already out of the with open and the reader has closed. So that's why in this case you would add a do all to kind of realize it, fully read it in before closing the thing. So yes, I should shout out who was it that mentioned this on Clojurians. Stuart, just Stuart. Well, Stuart, yes, thanks for the reminder. So yes, if you are using IO Reader, you probably should not do this. You should use with open. Back to the puzzle. So yes, Kaup asks on the live stream, are we doing a VM again? Yes, we are doing a VM again. It's a tiny VM, only has 3 instructions, 2 registers, if you count the program counter. Stick that in a function. Doing it again. So now we can run VM on parse input, test input. Yes, but we can also slurp IO reader. No, IO resource. I don't have IO yet, right? Add that IO resource. Puzzle inputs day8.text. How's that? 2051. Let's give that a go. All right, cool. Yeah, so Slurp does it for you, you know, like that's true, you know, you don't have to use IO Reader. You can also just slurp it, and like if you don't want to use the line seek, like the only reason I'm using IO Reader in some of these cases is because I want to use the line seek. But in this case, you know, you can just slurp it and split lines. If your files get too big to slurp and just call string split lines on it, you know, you'll have to come up with better solutions. But part 2. After some careful analysis, you believe that exactly one instruction is corrupted. Somewhere in the program, either a jump is supposed to be a nop or a nop is supposed to be a jump. No accumulated instructions were harmed in the corruption of this boot code. The program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. By changing exactly one jump or nop, you can repair the boot code and make it terminate correctly. So we could, for instance, flip this nop into a jump. it would create a single instruction infinite loop, never leaving that instruction. If you change almost any of the jump instructions, the program will still eventually find another jump instruction and loop forever. However, if you change the second to last instruction from jump to nop, the program terminates. The instructions are visited in this order. After the last instruction, the program terminates by attempting to run the instruction below the last instruction in the file. With this change, after the program terminates, the accumulator contains the value 8. Fix the program so that it terminates normally by changing exactly one jump to nop or nop to jump. What is the value of the accumulator after the program terminates? Okay. So here the question is, once again, is brute force going to be good enough, or do we need to be smart about this? Because so we can, we can basically go over the program one by one, change nops to jumps, try to run it until we find one that terminates. But of course, a lot of those programs are gonna, like the first part of their instruction of their the sequence of instructions they do until the change they hit one of the changes or thus changed instructions is gonna overlap, is gonna be the same. So in theory, we could reuse that state. But let's first do the naive thing. Now, I'm gonna duplicate this because we're gonna make a slightly different version of this. So far we do what's been asked in the first case, is just return the accumulator when we notice an infinite loop. In this case, we actually wanna have 3 cases. If we have an infinite loop, then let's just say infinite loop. If the program counter equals the count of the program, then we have successfully terminated. Then we've reached the end of the line, and we can return the accumulator, right? Because that's what we need in the end, to have the final version in the accumulator when the program exits. And for the rest, our general VM instructions are still the same. Cond requires an even number of forms, yes, so this is a else. Just using this keyword as a truthy value, it's quite common. I also could just have written true. But else is nice and declarative. So now, yeah, let's let program parse input. So I kind of want to build up a seek of programs where in each next program there's one instruction that has changed. So let's say I have a range of count program. So these are the indexes. So it's kind of yeah. It was a little bit of a red flag if you're dealing with indexes, but in this case, I think it's fine. Could also do some kind of loop recur thing where we split it up. I don't know. Gonna go with this. And yeah, let's do some more list comprehensions. I think that's actually gonna work quite well in this case. So we have our index. Now we only care about programs where it's a nop or a jump, get in program index and then the operator. And if so, we return the program but with the index operator swapped, change a jump into a nop and a nop into a jump, just using a map as a function here. Let's try this on our test input first. Yeah, and this, you do need the space there, I think, or Clojure is not happy. Yeah, so we have changed the first nop into a jump. Then we have changed the third jump into a nop. Then we have changed this jump into a nop. Yeah, that seems right. So then we can actually just kind of continue with this for forms, say let program, update in program, etc. And then let results run VM2 program. When not is infinite loop results. How about that? Oh. 2,304. All right, cool. Yeah, going a little crazy here with the for macro, but why not? I really sometimes I would just like, you know, like a let where you know you have these same keywords, so you can sort of write this stuff that otherwise would be this long nested code in sort of a more linear way. I like this stuff. Yeah, I hope that was instructive. Yeah, not too unhappy about our code today. I mean, it's fun to implement this kind of stuff. It's also not too hard, but it's you know, it's not as tedious as the data validation stuff we were doing earlier in last week. So I'll push this code to GitHub. It's still under AOC 2020. Do post links to your own solutions in the GitHub comments if you want me to look at them on the stream tomorrow. And looking forward what everyone else comes up to, and let's see what we get to do tomorrow. So thanks for watching, and see you soon.